All right. Well, thanks, everybody. I'm Doug Walker. I'm from the University of Kansas, and I've been involved with the Strabo project now for going on 10 years. This started out of an NSF workshop about the needs of field geology, structure, and tectonics to enter the cyber infrastructure age. This was in 2012 that we held that workshop. And then the first funding for developing StraboSpot came in 2014, and we've been working on it since. So what I want to do in this first talk is just sort of generally introduce to you what Strabo is about, how it works, give you a bunch of information about that. Then Nick will take some time for questions, I think, and then Nick Roberts will be giving a demo. Again, Q&A after that. After that, I'll talk about Tephra in particular. We've been working with the Tephra community for a while now, and a little bit of that will be in here as well. And then finally, we'll be doing a demo of Strabo Micro, which is really the system that helps you or lets you go from outcrop to thin section or SEM or whatever. Okay, next slide, please. All right, so we started out thinking about what field geologists need and how they worked. And what you see in the upper left here is a geologic map of an outcrop in the Twin Sisters area, the Klamath. And when we were starting to put together the ideas behind what a data system and how we would describe data in an outcrop, we came up with the following idea. Really, you have the outcrop area where you're out studying for a couple particular purposes, in this case, finite strain and rheology. Your interpretations and your data are broken down into smaller areas. So you can see that the red circles there are spots, what we call spots, where you're collecting data. The arrow to the upper right is showing basically an outcrop where data was being collected on a dike, and that we were able to, the researchers were able to start making interpretations about finite strain and rheology. So for each of those sub areas, you're basically mapping there, collecting data, and those are standalone observations, but they're part of the bigger outcrop, part of the bigger context. And then we can go down from there to a thin section level across polars there, where you see data connected to basically the thin section, back to the outcrop, back to the map. Go ahead and click. Great. So what we're putting together here is the ability to, say, go out in the field with an iPad shown here, collect field data, as you can see on the upper row of slides, where you collect an oriented sample, go to a thin section, or collect a rock, go to a thin section, and then go to fabric data, for example. So the idea behind StraboSpot was that we had these spots that apply to a particular area, and that everything is scale independent. You're able to go between scales pretty much seamlessly, going up and down. The geology part of this and sample collection and that we're doing in Strabo Mobile, StraboSpot app that you'll be seeing, and then Strabo Micro can handle the rest of this. Our plan is to eventually have those two merge together and be able to have seamless operation. Go ahead. All right, so a spot is an observation or relationship with an area of importance. So in the lower left here, you see a fold where we have strikes and dips of layering and a fold axis. And basically what you want to record here is just the information about the layers, strike, dip, and facing, but you want to let those go ahead and be related so that you can keep track of measurements taken in the same layer, for example. And this is where we ended up with on StraboSpot using a graph database system as opposed to a relational database. And basically putting this structure together is easier and very flexible. So we have spots with individual measurements, and then we'll have a relation or labels that tie the two measurements together. Next, please. And that can cover any set of data that you want. So for example, here we have around this fold a measure of the fold axis, but we also have strike and dip and facing and bedding. So now we want to apply to this all of these measurements that they're part of the same fold. So again, a graph sort of approach to collecting the data, and that way you can keep things that are related together, and you can have any number of relationships between different spots or spots within a spot. For example, in this case, that fold will form a single larger spot that you'll then have measurements with. So the idea here is that you're able to flexibly collect data, and you're able to go between scales without any sort of hitch or any problems at all. Next. So this, we described this approach and this data system about 3 years ago in a paper in Geosphere. It's open access, you can get it. And at that point, we started working in structural geology. That was the original path we were taking, was StraboSpot for structural geology. So collecting field measurements, collecting structural data, grouping structures together, et cetera. So this is the data approach that we took. But at the same time, we recognize that for any sort of app to be useful, and for any system to be useful, there had to be a good interface, and you had to have the response of people in the community. So from the start on our effort for StraboSpot, we put together workshops and brought people together on different types of structure, different tectonic settings, to really come up with a lexicon or vocabulary that described what they were doing. The other thing, go ahead and click. The other thing is that we work on all this so it fits the user's workflow. So this is something new for a lot of geologists, going out in the field with a tablet and collecting data. That's a different exercise. And people are used to using paper, pencil, maps, and field books. What did we want to do for StraboSpot? Now, you could make a system that was basically an electronic field book and map. There is some aspect of that, but you also want to be able to integrate more functionality, like taking pictures, taking measurements, et cetera, and take advantage of being able to basically use everything you could with the app, as well as your most of the things that you're comfortable with already. So that's where we went into with the design work here, trying to put this together for people. So what we've done over the last 8 years or so is produced a couple different versions of StraboSpot at this point that we're moving forward with, and I'll explain those in just a minute. Next slide, yeah. StraboSpot is in 2 versions now, Strabo 1 and Strabo 2. Strabo 1's been out for a few years now. It runs on Android and iOS. And Strabo 2, we're just completing the first build of it. And well, sorry, no, we're completing many builds of it. We're about to put out a newer version, and it has a lot more graphical capabilities. If you look at the bottom here, on the left is the Strabo 1 interface, showing some lines on a satellite image, but your customization and changing things around were fairly limited. On the lower right, you can see the Strabo 2 interface. Basically, we designed it to work on a tablet. Strabo 1 will work on phones, but most people don't use phones for data collection. So we went to a tablet-sized design, and you can see here customizing rock units, structural features, contacts, et cetera. And then in the far right, you see strikes and dips sitting in there that are taken with a built-in compass. So the way it works now is you can see the menu on the left, being able to access your data, manage it. You can look at images. You can work with image-based maps, which are maps formed by pictures that you take in the field. And then you're able to put in custom maps and custom data layers. And Nick will show a little bit of that later. In the lower right here, far lower right, you can see a tag, a compass, a hammer, a letter, which is signifying notes, camera for pictures, and then sketching. You can actually get a lot more different tools open on this if you want, but I'm not going to go into those at this point. Okay, next slide. So this is, again, a close-up of the interface. You can see the map here, the geologic map of an area with some faults. Different colors are used for different rock units. And then the orange spot in the center is highlighted, the NT24, where you're showing bedding coming through here. So this is the mapping and basic data collection interface for field data. We've gotten a couple of awards for this. This is now working with vocabularies, not just for structural geology, but also for petrology, metamorphic and igneous petrology, and sedimentary geology we'll get to in a minute. Sedimentary geology is quite important for thinking about the Tephra community. So this is that interface. You have very great flexibility in collecting data. Go ahead and go to the next one. This is a different mode of operation that people can use, and we call it StraboSed. Basically, for sedimentologists and stratigraphers, their map or their mode of data collection isn't on a map. It's more in a stratigraphic context measuring section. So what the StraboSed version does is it allows you to add intervals, collect data, move units around, and you can actually match imagery on the fly as a base map for your measured sections. So you can see examples of that in here. StraboSed has been out for a little while now. We're just turning this now into version 2. This is all in version 1 right here that I'm showing you, and we still are constructing sections in version 1. Version 2 can display this, but over the next few months, hopefully by the end of the summer, we'll have the full functionality for sedimentary geology in here as well. Next. And then Strabo Micro, I'm not going to talk much about it since we're going to get a demo of it, but it's meant to look at thin sections and then be able to relate data across these micrographs, what we call micrographs. All right, next slide. And then finally, we have a set of tools that's out by under the name Strabo Tools. It's an iOS application where you can get images of a rock. You can do crude modes on it, fabrics you see in the lower left, and just basic color index. This was developed for metamorphic rocks and igneous rocks. This is a set of routines that Alan Glazner at University of North Carolina put together. So again, these data can come in and come into StraboSpot. Okay, thanks. So again, getting back to the fact that we try to get users involved as much as we can, and our primary purpose of developing this is to fit user workflows. And so this is a group that we had together in 2018. Marcus Bursick's on the left here, second from the end. And so this was a petrology workshop where we were working on the petrology options for StraboSpot. And again, we take people out in the field. This is about 25 people that we were working with on that, revising interfaces, changing things around. This group was pretty fundamental to where we went with Strabo 2 as well as Nick Roberts' design. Anyway, so this is the sort of approach we've always taken, lots of feedback, lots of people involved, and then building that from there. Next. It again fits user's workflow is the whole aim of this. Okay, next. So I'm not going to go into this too much. We got a good discussion of this in our last seminar last week, but StraboSpot follows the FAIR principles. Next. And StraboSpot is FAIR. The data are all recorded, and you can upload, download, search the data. You can make your data available to other people. You can serve the data in GeoJSON format or GIS. But one of the important things here is that it records the full metadata with any sample. So for example, when you collect a sample or you collect information, you get a location and you get a label for the sample that you can communicate to other people. Every spot, every observation is unique. Next. So you're able to control, you can collect your data in the field and then you upload it to the StraboSpot server. It's located on the Exceed NSF platform. We're just moving over to what's called the Jetstream 2 platform. But anyway, so you control your data and the access to your data. So next slide. So the data are organized, I don't need to go into this, but they're organized in ways that you can make them public or private. So this is just an example where you can see this red pass range set of samples is public. That means that you can come into the website, look for those rocks, look at the data about them and get that information. The others you see in here are private. That means that basically they don't come from any search. Nobody can get to them except for you with your password. Next. The other thing you can do here is you can import, but you can export files and projects. So you, for example, shape files, KMZ, XSL, Excel, a lot of different possible formats, your photos. One of the ones I'll just show now is the field book option. Next. And basically what this is you can pretend that your StraboSpot project is just a field book. So you can get the spot names, it has the location, it has the date that they were put in and time, and any photos that you take and any other data. So it's kind of like the super notebook where actually when you're taking pictures, it goes into your notebook as well. So everything is done in context. Next. And then, of course, for other people using this, we have web services so that other data groups can just interact with the database through web services. This is just showing the documentation for that. Next. So go ahead and click. Yeah. We have the field component, the Strabo micro component, and then we're also working with the experimental deformation community to basically link naturally deformed rocks with experimentally deformed rocks and trying to put that together. Next. So, and then at the end, you can manage your data on the web with the StraboSpot app as you're seeing. Next. So what we're able to do with this, and the purpose of StraboSpot is to work out on the long tail of data, basically so that you can document observations, document what you're doing, and be very specific and reproducible about what you're putting together, reusable and reproducible. Next. So that's my intro. I guess we're going to take a couple minutes for questions, and then we're going to move on to a demo. Thank you.
We do have one question in the Q&A. If you have other questions, please type them in there. And the first question is, what is a graph database?
So graph database is more or less the way that things like Facebook work, where you have individual data entries those sit on their own, and then you can link between them. So basically the entries are called nodes, and the connectors you can call edges, or in our case, relationships. Those can contain any sort of information you want. It goes into the back end stored that way. It's a way that makes it very flexible for users to use. You don't really have to worry too much about the database details in this. It's all put together, and then it can spit it out in whatever format. Well, a limited number, but different formats you might want.
All right, how about we move on?
Okay. So I'm going to hand it over to Nick.